Welcome back, everybody. This is going to be our solving quadratic equations by completing the square home review part two. But more in this case for this part two is more on how we can solve by completing the square. Um, Not necessarily about solving the quadratic equation, find the roots, but to be able to rewrite the equation into vertex form. Okay, and so if you didn't catch the first video of solving equations by completing the square, definitely take a look at that one. The technique we're using is definitely the same technique as before, just slightly modified. Okay, so you'll see how that works out. We definitely follow the same steps, except for one small thing. We have a y equals involved here. Okay, all right. So in vertex form, we definitely want to make sure that we have our equation in the form of a times x minus h squared plus k. So for this one, I'm using question number 8 from the homework, and so except instead of equals 0, I said equal to y. Our very first step is very similar to what we did before. We're going to subtract both sides by 23, kind of move that constant over. And so now we'll have y minus 23, but plus blank, equals k squared minus 12k plus blank. Okay? So the only difference is that you have a y there as well too. It's really very much the same thing now. Okay? And so our b value in this case is negative 12. So taking b over 2 would mean we get negative 12 over 2, which is equal to negative 6. We then take that negative 6 and square it, and we square that, we get a positive 36. So we put a 36 in each of the blank spaces, just like we did before, all right? So now on the right side, we're going to factor this, but although we don't really factor because we know in this case, we're going to get k and k, and that b over 2 value is what we put into here, minus 6 and minus 6, or k minus 6 squared. So that's on the right side. On the left side, we're combining the negative 23 plus 36 will give us a value of 13. So we can get y plus 13 equals the k minus 6 times k minus 6, or y plus 13 equals k minus 6 squared. Finally, this is the last step we're going to use. We're going to get y by itself and subtract both sides by 13. So now we have y is equal to k minus 6 squared minus 13. And this will be our vertex form of the equation y equals k squared minus 12k plus 23. The vertex form, of course, is y is equal to a times x minus h squared plus k. This form allows us to find the vertex. In this case, we see the vertex is going to be 6, comma, neg 13. Now, do the questions get more challenging? Yes, they do. Okay? But we're using completing the square to be able to find the vertex form. Okay. Let's try another problem. This is question number 20 on the sheet, which is y equals. Here, y equals 2 times x squared minus 5x plus 67. So what we're going to do is we're going to, in this case, we're going to not divide by 2. Instead, we're going to factor out 2. Okay? Now, what I am going to do is, maybe I should have done this before from the beginning. I should subtract the 67 both sides. So let me just start from there. Yeah, we'll do that instead. Sorry about that, ladies and gentlemen. I should have done that instead, though, so minus 67. Okay? So we have y minus 67 plus blank equals 2x squared minus 5x plus blank. Now, if I was trying to solve the roots, I'd just divide everything by 2. But here I have to factor everything, okay? And so here, in this case, I'm factoring out a 2 because I want that x squared by itself. So I have x squared times 5 over 2x plus blank is equal to y minus 67 plus blank. I will make sure the values are the same. Okay, so, and we'll test to make sure that afterwards too, just to make sure we get that done correctly. Now, you're probably saying to yourself, oh no, Mr. Gong, this is no good. No good. Because here we have a b value of negative 5 over 2. Oh no. Oh no. Well, b over 2 would just be negative 5 over 2 divided by 2. Now, negative 5 over 2 is really the same thing as negative 2.5. If we divide that by 2, we get negative 1.25. Fraction-wise, this is equal to negative 5 over 4. Okay? If I square negative 5 over 4, because that's the next step, I square the top part, so negative 5 times negative 5 is positive 25. And in this case, 4 times 4 is going to be 16. So in that parenthesis, I am putting here 25 over 16. The problem with this is that I cannot put that same value into the left side because in the end result, I'm multiplying everything by 2. So on the left side, okay, the equivalent value would be 2 times 25 over 16, which would be, in this case, 25 over 8. Okay? Now we say, oh, the factoring part is going to be so brutal. Again, we don't have to worry about this much. This part here factors nicely. You're saying, how is it factor? We got this value of negative 5 over 4. Okay? So in here, we'll have x minus 5 over 4 times x minus 5 over 4. Oh, times 2, of course, on the outside. Because 5 over 4 times 5 over 4, negative 5 over 4 times negative 5 over 4 is positive 25 over 16. And negative 5 over 4 plus negative 5 over 4 is going to be negative 10 over 4, which is the same as negative 5 over 2. So this works out nicely. And we didn't have to worry about factoring because we found the number we're going to plug in. So this now becomes 2 times x minus 5 over 4 squared. Now, on the left side, we have, in this case, negative 67 plus 25 over 8. Okay, and so here, we're going to combine those two. So 25 over 8 is the same thing as 3.125. And we're adding that to negative 67. Well, if you add that to negative 67, we're going to get, in this case, negative y minus 63.875. Okay? And that's equal to here. So y minus 63.875. Now that's the same as a 7/8. Okay? Now, to get y by itself, we add this 63.875 to both sides. And we end up getting y equals 2 times x minus 5 over 4 squared plus 63 and 7/8. That's our vertex form, which means our vertex would be 5 over 4, comma, 63 and 7/8. Okay? which is not very nice kind of not kind of function to look at, no. But we can also check this to make sure. Okay, so next full page for you guys to see this now, and we're going to take this and try to find the vertex the other way using our axis symmetry. Okay. So we said in this case, y was equal to 2x squared minus 5x plus 67. Our a value is 2, our b value is negative 5, and our c value is 67. So if we use our axis symmetry, which is x equals negative b over 2a, we get negative of negative 5 over 2 times 2, giving us a x value of 5 over 4. Okay, and now we're going to plug in this 5 over 4 into our function. Y is equal to 2 times 5 over 4 squared minus 5 times 5 over 4 plus 67. Well, we distribute this here, we get 2 times 25 over 16 minus 25 over 4 plus 67. 2 times 25 over 16 becomes 25 over 8 minus 25 over 4 plus 67. And 25 over 8 minus 25 over 4 is going to be negative 25 over 8. Because, 25 over 4 is the same as 50 over 8, so 25 minus 50 is negative 25 over 8 plus 67. Okay, and so again, 25 over 8, we said before, is the same thing as 3 and 1/8. So we have 67 minus 3 and 1/8 is equal to 63 and 7/8. And that's our y value. So our vertex is going to be 5 over 4, comma 63 over 7, 63 and 7/8. Our a value is 2, and so we use our vertex form, y is equal to a times x minus h squared plus k. We have y equals 2 times x minus 5 over 4 squared plus 63 and 7/8. So we found our vertex form the other way, and we got the same exact thing. So let me full page. Okay. So we have to move the constant over first, factor out the 2, and we're dealing with fractions but the same exact way. We'd be very careful about adding, if we're factoring out the a value, we have to remember that once we find that the number plugging in into our parenthesis way back here, this 25 over 16, that on the other side, we're multiplying by the a value. That's the true value we're adding to both sides, okay? So definitely something to consider in this case. It's a little tricky. When we practice, we'll definitely get a better handle of this though, okay? All right, ladies and gentlemen, thanks for watching. I hope this was helpful to be able to find the vertex form of a parabola or a quadratic function by completing the square. So completing the square does allow us to not only solve for the roots, but also to help us find the vertex as well. Thanks so much for watching, everybody. I appreciate you guys here. Please, if you liked the video, please give it a like, and of course, subscribe to the channel. All right? Take care, everybody. I'll see you guys